as I said, I work at IOMED. We trying to accelerate clinical research by standardization of clinical data, and we focus especially in clinical tests. So that's why our talk in the collaborative showcase was about how to improve or how to include new schemas into the OMOP CDM to store the output of NLP pipelines. So as you know, most of the data that is, or a large proportion of the data generated within hospitals every day is stored as free text, as clinical notes, reports, and so on. And current NLP, natural language processing technologies, are able to extract and encode most of the information that is stored here. I mean, both name entity recognition, I mean, to extract the concepts, so let's say the entities in the text. I mean, let be symptoms, diseases, drugs, or whatever, and name entity linking, how to map those entities into concepts, into standard vocabularies. Those processes are quite complex. I mean, and the technology is able to do disambiguation and other kind of strategies, but still is different to capture all the context about a disease, a drug. It was actually happened. It was a negative affirmation. It took place in the past. It's a reference to the future. It has some degree of uncertainty. So there is a lot of context that make more difficult to capture all information from an entity. So it's not just a matter of say, okay, here they are talking about a headache, for example, in this example. And most of the technologies that are currently used, neural networks, deep learning, and so on, are mainly probabilistic. So we need to have the capability to store somehow the traceability to how the information was extracted and what is the evidence also from this process. No? We are always talking about real world evidence. We need also a natural language processing evidence. And I mean, the importance of NLP for clinical tests is already captured in the CDM structure. We have the Note NLP table, but somehow within our operations with the hospital that we have been working with, we found somehow limited to our needs. So it's focused mainly on entity recognition, but all the metadata is just stored as text. So it's difficult to make queries on that metadata, and that's why we extended for our purposes, for our own purposes, the schema. I mean, we converted that NLP table into a collection of tables, a full schema that we are using. The schema has two parts. On one side, on the upper side, we have what we call the NLP pipeline related tables, where we store information about the actual system. I mean, all the versions, the different components of the pipeline that are used to extract information and for all the context information, the disambiguation, etc. So how we extract all the context about the entity, and the lower part of the schema, what we call the node span, is the node span will be somehow the extension of or a reduction of the node NLP. So we collect where what is the part of the text where an entity was found. And we extend that table with extra information. Somehow we can have all the concepts that can be assigned to that entity that has been extracted. If that entity is a quantity, is a number or quantifier is stored in a different table. If it's a date, it's stored in a different table. If it's something that can be mapped to a concept ID, it goes to concept. And also we need to capture all the relations. Well, here is you can see it better. And the NLP relationship table will capture relationships between two entities extracted in the same node. Okay. All these quantities, dates, and concepts, they will be assigned a probability. As I said, most of the current technologies are probabilistic, so we can be certain of something just up to a certain probability. So, and through the node span, we connect to the rest of the CDM model through the node table, and most of the relationships, concepts, date precision, units concepts, they will map to the concept table. So that's how our proposed schema is connected to the rest of the CDM model. Okay, and then we have, as I said, we have a set of tables to capture the complexity and the versions and the steps of the pipeline that has been applied for the extraction of the entities. Okay, so to ensure that we can trace back how the information was obtained. Okay, so for example, we are able not only to capture that. Okay, we detected, for example, a condition, psoriasis, in a clinical node, but also we can have if this was the primary diagnosis, or is a reference to an historical history of psoriasis, or if the disease is present at this moment. Okay, so we can capture much more information than, we can store, we can represent in an easy way, so that it can be queried in an easy way than with the NLP, just with the node NLP table.
All right, Alberto, I just want to give you about 30 seconds to wrap up, and then because we want to make sure everybody has time.
Okay, we are currently using this in 5 hospitals. We have more than 70 million clinical nodes processed. Just for giving you an example of how this improves just using structured data. For example, this is an example for a dermatology study. From the structured data, we will find around 500 patients, and then this could be, we have up to 3,000 patients for a given cohort that we will extract just given the NLP data. This supposes a lot of a big data volume. So for every node, we can extract up to 200 concepts on average. So the amount of data increases enormously. But we think that this is the way to go. So this is an open proposal to the community, and to create a new schema. We already work with the NLP group, and we have already submitted a proposal using a proposal issue in the GitHub for the common data model, and we are happy to receive comments and to carry on the discussion there. So thank you very much.